Good day, everybody. Today we want to look at how to find the change in the fuel efficiency, or miles per gallon, based on a short little trip. So here we can see the start of the trip will occur when I'm already at 291.5 miles, and my current miles per gallon, current fuel efficiency is 50.9 miles per gallon. The little trip is just 6 miles on top of that 291.5. And my fuel economy here is given as 64.5 miles per gallon. Very good. You see it's like a Prius, so amazing miles per gallon there. So we've got a little trip, change in miles of 6 miles, and then the fuel efficiency of the trip, 64.5 miles per gallon. Or to sum up, there's the beginning, we're already at 291.5, current fuel efficiency 50.9. You do a little trip of 6 miles and you get a certain efficiency, in this case 64.5, so above. So we figure this is going to go up, but by how much we shall see. So again, here's the details. So we're going to approximate the change in the final fuel efficiency, for trip A, after we do this little trip and add it onto it, by using differentials. So what I'm going to use as my variables, M for miles, G for gallons used so far. That's for trip A, which is at almost 300 miles. E, miles per gallon, the MPG efficiency. So the efficiency is given and the miles is given, but I don't know the gallons used. But I'll still do the differential of miles over gallon. So the differential dE will be partial E with respect to miles, dm plus partial E with respect to G, dG. And so if I take those derivatives, derivative partial with respect to m, will just be 1 over g, got that there, and then the partial of e with respect to g will be negative m over g squared. So I've got that there, and then dg, and so this differential we'll use this to approximate the true change in efficiency is roughly then 1 over the gallons times the change in miles minus the miles over gallons squared times the change in gallons. But again, we don't know gallons, but we do know fuel efficiency, and so we can use that. So for example, for on a short trip, we know the efficiency of the little trip, so that's a little tiny change in miles over change in gallons. If we solve for the change in gallons there, the delta G is actually 1 over the efficiency, fuel efficiency of the trip, times that change in miles, or the miles of the little trip. So I can put that into this delta G there. So now I have, same thing, delta E is 1 over G delta M minus M over G squared. And then for delta G, I put in my 1 over ET delta M. And I'll just separate out a little bit. I've got a m over g squared. I'll write that as m over g times 1 over g. So that was the only change here. And again, I don't know gallons, but we know the efficiency is miles over gallon. So 1 over gallons is your E over M. So if I put that in for my 1 over g, so I've got E over M, delta M, minus, m over g is just E, 1 over g is E over M, and then 1 over t delta M. So I've got the change in efficiency is roughly going to be, I'll factor the E out first, and I've got delta M over M minus E over ET. Again, I factored out one of the E's out front here. I'm still left with one more E over ET, and I've got a delta M over M. And again, I can now factor out delta m over m. I put that at the end. So the change in efficiency is going to be your current efficiency times 1 minus your current efficiency divided by the efficiency of the trip times change in miles over miles. So in particular, if the efficiency of the trip is exactly the same as your efficiency before the little trip, then this will be 1, and well, of course, there'll be no change in efficiency, right? So if I was going 50.9 miles per gallon, or I was getting that, and then on a trip I get 50.9 miles per gallon, well, there'll be no change in my miles per gallon that way. If your efficiency of the trip has better miles per gallon, so it's bigger than E, then this will be a positive number and your fuel efficiency will go up. And conversely, if it's smaller, right, so you get worse efficiency on the little trip, then this will be a number bigger than 1, which means this will be a negative, and so your new efficiency would be lower, right? So you can get a negative change in efficiency. So there's our formula. Again, I have it here. So for that trip we did, we had 50.9 miles per gallon at 291.5 for our start, and then we did the little trip of 6 miles, that was 64.5 miles per gallon. So if I put it in here, I get about 0.221 miles per gallon. So my fuel efficiency should go up by about 0.2 if it's only reading to the tens place. And that's what happened. This is the what happens afterwards. So now we're at 297.5 miles, and our current fuel efficiency went up by 0.2 as predicted. So now we see how a little trip will affect your fuel efficiency thanks to differentials. Yay. Okay, so hope you enjoyed that, and start to see differentials everywhere you go. That would be my goal. Anyway, have a nice day.